Section 5 is about parts of similar triangles, okay? So there are two new segments that we're going to talk about, and then one other segment that we've talked about before, but only in the context of defining it, not ever really using it, okay? But first new segment is an altitude. Think of the altitude like the height of a triangle. Okay, it starts at a vertex and it is perpendicular to the opposite side or an extension of the opposite side. Okay, if we have an acute triangle, the altitude will always be inside the triangle. Okay, if we have a right triangle, the altitude can be inside. Okay, but it can also just be one of the sides of the triangle. Okay, and then if we have an obtuse triangle, the altitude, again, it can be on the inside, okay, but we can also have altitudes on the outside of that triangle, okay. If two triangles are similar, then the lengths of the corresponding altitudes are proportional to the lengths of the corresponding sides, okay. So here we've got triangle ABC similar to triangle FGH, okay. We'll say the side lengths are in the ratio of A to B here. All right, whatever that side length ratio is, the altitudes are going to be proportional as well. Okay, so we say A to B is going to equal AD to FJ. All right, a median, think of the median of the road as the middle of the road, okay? The median of a triangle is a line segment whose endpoints are a vertex and the midpoint of the opposite side. Okay, so essentially we've got to go through them from the vertex through the middle of the triangle to the middle of the opposite side. Okay, and just like with altitudes, if we've got two similar triangles, so here we've got ABC similar to WXY, then the medians are proportional to the lengths of the sides. So if our side lengths are in the ratio of A to B, our medians are proportional to that. CD to YZ. Okay? And then we've talked about the angle bisector before. It's that line segment or array that bisects an angle, cuts an angle right in half. Okay? If we have two triangles, for instance, KLM similar to QRS, then the lengths of the angle bisectors are proportional to the lengths of the sides as well. Okay, so we'll say B over A for this one. And if we say B over A, LP, the length of LP, that angle bisector is going to be proportional to the length of RT, or the angle bisector of our second triangle. Okay? So, just a couple of examples. Here, these indicate that AP is an angle bisector and FQ is an angle bisector. Okay? We know triangle ABC is similar to FDG. So, I'm going to say 12 over 15. That's a pair of corresponding sides. Okay, and since I said 12 over 15, 8 and X are going to be proportional to that. Okay, so 8 times 15 is 120. Okay. So the length of the angle bisector of triangle ABC is 10. All right. The second one here, we've got both medians. Okay, we go from a vertex to the midpoint of the opposite side. So we've got the lengths of both of our medians. I'm going to say 13.5 over 9, okay, is equal to the ratio of side lengths. And since we're looking for that, looking for X over 3. 9X equals 40.5. And we divide that by 9. So just this portion right here is 4.5. Okay? Now the angle bisector is a little bit got a little extra special property, okay? If we have just one triangle, okay, and we have the angle bisector, one of the angle bisectors of that triangle, the angle bisector of the triangle separates this opposite side into two segments that are proportional, not pair proportional, that are proportional to the length of the two sides, okay? So, JM here is our angle bisector of angle KJL. All right, whatever proportion JK over JL, or excuse me, whatever ratio JK over JL is, these parts now are going to be proportional to that. So KM over ML. Okay? So here, these are my sides. Here, these are my parts. Okay, but this direction, JK and KM both, they come from the same side of my angle bisector. And JL and ML come from my same side, the same side of my angle bisector. Okay? So, we'll do the first two examples here, and then you can try the third one on your own. One nice way to look at it, think of the angle bisector as an equal sign, and you can throw fraction bars in there, and this sets up our proportion for us. Okay, x over 4 equals 13 over 6. All right, that's just a little trick. If you want to do it like we did up here, we can also set up x over 13 equals 4 over 6. Okay, either way, we cross multiply, we get 6x equals 52, and 52 divided by 6 is 8.6 repeating. Okay. Example 2 here, I've got 6 and 14, those are my sides. Ooh, not 16. 6 and 14. Okay, 6 came from above the angle bisector in this picture. So in my second ratio, I've got to look above my angle bisector again at the part that's above my angle bisector, which is just x. Okay, now this other part here, if I know I start with 18 and I have to take x away, I can't use this part of it, okay, because I already used it here. This second part is going to be 18 minus x. Okay, take whatever you start with and subtract that part to figure out what's left. Okay, cross multiply. We get 14x equals 6 times 18 is 108 minus 6x. Okay, don't forget we've got to take, when we cross multiply, that 6 times that whole quantity. Okay, add 6 to both sides, 20x equals 108. When we divide 108 by 20, we get 5.4. Okay, try the third example on your own. Check your work in the completed notes.